safety then. So if we look at Newton's second law, that is F equals ma, but we know that the acceleration is the change in velocity divided by time, which is the final velocity minus the initial velocity divided by time, which is, let's call that v for the final velocity, u for the initial velocity over time. So if we then stick that back in here, we have F equals mass times v minus u over t. Now you'll recognize this from one of the equations of motion that we've looked at. But if we multiply this out, we've got mv minus mu divided by t. And of course, these are momenta. So this is your final momentum minus your initial momentum divided by the time. So what you have here is the rate of change of momentum. So you say, well, what's that got to do with safety? Well, a lot actually. This is pretty much what Newton said. He didn't say, oh sorry, I didn't mean to put that up there. He didn't say that force was equal to mass times acceleration. What he said, was that force was proportional to the rate of change of momentum. So what do you say? Well, let's consider a car traveling at, let's say, 30 meters per second, so it's moving, and then it hits a wall and it stops. Right? So it's going to go from 30 meters per second to stopped. That's a given, right? We have no control over that. We are driving at 30 meters per second, we drive into a wall, we're going to stop. But the resultant force applied to us, to the car and therefore to us, equals the change in momentum divided by time. So whilst this bit is fixed, if we could make this bit longer, we'd have ourselves a reduced force. The bigger we make this, the smaller we make this for a given change in momentum. So this is the principle behind crumple zones on cars. Cars are designed when they crash. If you were to consider just the bonnet of the car, just the front end of the car, when they crash, they are designed to crumple. Now you can see that in two ways. You can see that in terms of absorbing some of the kinetic energy of the crash and storing it in the deformation of the car. You can see it in terms of crumpling it takes longer. A longer period of time is required, and therefore for the same change in momentum, a smaller force is applied. Crumple zones. Seatbelts. The same idea. What the seatbelt does is to apply a smaller force over a longer period of time. Airbags. Amazing devices. Same thing. It applies a smaller force over a longer period of time. The periods of time involved here are not big, but they are bigger than they would be without them. And so the force is reduced. You're not going to walk away from a high-speed accident feeling great, but you might walk away as a consequence of these devices. So you've also got egg boxes that work on the same principle. Bubble wrap works on the same principle. Corrugated, that's supposed to be an A, corrugated cardboard boxes work on the same principle. Playground surfaces, you know, you've got these squidgy black playground surfaces. They work on the same basis. They're made of old tires. All of these, what they do is, for the same change in momentum, they make a greater period of time be used for that change in momentum, which means the resultant force is smaller because the force is the change in momentum divided by the time. That is your standard answer for the same change in momentum. A longer period of time is taken. So the rate of change of momentum is smaller, and the resultant force is proportional to the rate of change of momentum. So that's really the heart of car safety, egg safety, fragile device safety, and child safety. If a child falls off the top of the slide onto concrete, the time it takes for them to stop is shorter than if they fall onto this playground surface that we have these days. So because the period of time taken is longer, the rate of change of momentum is smaller, and because the resultant force is proportional to the rate of change of momentum, then the force on the child is smaller and they're less likely to be seriously injured. That's safety. Now notice I said longer period of time. I did not say time is longer. I did not say the time is longer. I said a longer period of time is taken. The amount of time taken is greater. Do not talk about time getting longer, because it doesn't. Not in this context. Okay? So that is safety. And you will find questions on safety, on Isaac Physics. You will find questions on safety on my question sheet that I have issued to you if you're in my class. And you will find questions on Great Gorilla as well.